Welcome to this If Oxford event, Glow Your Own. This is 6 weekly workshops to learn how to do some coding and make something for the Oxford Christmas Light Festival that's happening in November. Hopefully you've got your bits of technology. I've got mine, my little box of tricks here. We're going to be kind of exploring that. We're going to be using a program called Tinkercad. So we might need you to make it so you can open up another web browser and have your Zoom showing, so you can get the instructions from the video, and also use another website window to kind of get things moving there. We've got a couple of people who know how to do coding. We've got an artist in the room, and then there's me, who doesn't know how to do coding all that much, and I'm not that great at art. So I'm hopefully in your shoes learning how to do this for the first time too. So Sarah's from Science Oxford. So maybe Sarah, if you could just wave or say something so we can get you on the screen.
Hi everybody.
So that's Sarah. And then we've also got Sophie from the STFC Rutherford Appleton Laboratory. So Sophie, if you could say hi.
Hi everyone.
So Sophie and Sarah are going to be leading the workshop. And then Tommy, so if you could say hi too.
Hello.
So that's Tommy. So Tommy's going to be helping develop some cool ideas to make the lovely lanterns and turn this little breadboard, is what the kind of little white thing in the box is called, and the LEDs and the little Arduino, into something that's really cool. I'm going to pass you on to Sophie and we'll take it from there.
Fab, thank you very much, Dan, and thank you all so much for coming. It is lovely to see so many of you here. I hope that you enjoy the session. So like Dan said, I work here at the Rutherford Appleton Laboratory, which is an amazing place. You should all come visit us once we're allowed to move around the country again. We do really exciting big science. We've got some of the biggest lasers in the world. We build things and we test things to go off into space, do all kinds of really fun things. And all of that needs coding and computers. So the kind of stuff that we're going to be doing together, that's the kind of stuff that we do at our amazing laboratory. And I'll tell you a little bit more about it at a later point at one of the other sessions. So I'm just going to share my screen so you can see what I'm looking at. Here we go. Right, so welcome to the first of the Glow Your Own workshops. Today is a very special day. There we go. Can you all see that? Yep, fab. Brilliant. So today is a very special day because it is Ada Lovelace Day. Happy Ada Lovelace Day, everybody. Does anybody know, has anybody heard of Ada Lovelace? Would anyone like to type in the chat or something, or raise your hand if you want to answer who you think this lady, Ada Lovelace, was? Oh, I've got some answers in the chat. I'm just bringing them up. She was a mathematician. Yep. First computer programmer. Yep. Fantastic. You guys are on it. Maybe I should take a break and you should do this. That would be quite relaxing. So yes, Ada Lovelace was amazing. She lived about nearly 200 years ago. But even though she lived all that time ago, she's often seen as the first computer programmer. She called herself a poetical scientist, which I think is a lovely phrase. So she loved the arts, but she also loved the sciences. And she worked with a man called Charles Babbage, who designed the first computer, or the first mechanical computer. And she created a set of instructions, a code, just like we're going to do, that a mechanical computer would undertake to solve a problem or to do something. So she was the first computer programmer, and nearly 200 years ago. So she was really pretty awesome. And she, so we think that she's definitely worth having a whole day named after her. So happy Ada Lovelace Day, everyone. If you want to go and read about her, there's lots of stuff about her on Wikipedia and on the internet. If you'd like, you can send us an email. We can send you some links, because she was absolutely fascinating. And one of the cool things about her was that she called herself a poetical scientist. So she didn't just like the sciences, she was also very interested in beauty and arts. And what we're going to do over the next 6 weeks is we're going to combine the two. We're going to learn how to do some coding. We're going to build some circuits, but we're going to use that to create some beautiful lights for the Oxford Light Festival that Dane mentioned earlier on in the thing. And Tommy is going to help. Tommy is our expert. He's going to help us with the design and with thinking how we can make it really beautiful if we want to create a message or something like that. So I'm really excited to see what you come up with over the next few weeks. All right, so Ada Lovelace was awesome, and we love to celebrate her. So I think we should follow in her footsteps and start to think about how we can do some coding ourselves. So I think you should all have one of these. This is an Arduino. But can anyone tell me what an Arduino is? Have you heard of one before? You can type it in this chat. Oh, sorry, my chat is hidden. We've got some great things to do. Can anyone have an idea about what an Arduino actually is? Oh, yes, excellent. Katie, it's one of those things that you've got in the box. That's exactly what it is. Can anyone explain what it does or anything? I'm just gonna, gosh, there are so many of you. This is awesome. All right, so an Arduino is what we call a microcontroller, which is a really long word, but it's actually a very simple thing. So micro means small, and it's called micro because it's a small thing. And controller is exactly what it means. It's a controller. It controls other things. So it's a small thing that controls other things. And what you're going to use it for is you're going to use it to give instructions to your lights so that they can go in patterns, so that they can turn on and off to create our beautiful, beautiful light displays for the Light Festival by the end of this thing. So we'll just show you a little bit about all of the different things. If you want, you can get yours out of the box so you can see it in person. And I'll show you all of the different bits and pieces on there because there are lots of different bits and pieces that we can use. Oh, Dane has his. It's kind of disappearing into the background, but I believe it's there. Fab. So you can see all of these different things. There's a big silver thing at the top, and that is where you plug it into the computer from. So you've got a lead with you, and you can plug one end of the lead into that, and you can plug another lead into the computer. And that's how the computer can send its instructions to the Arduino. So the code that you're going to do, you can send it to that. We've also got all of these different pins. Oh, sorry. We've got a whole bunch of different little sockets that you can pop wires in or LEDs or things in. So you can see the little holes at the side. They've all got numbers or letters next to them. Now, all of these ones along here, can you see my cursor, everyone? Can you see the mouse? So all of these ones, these are what we call our digital pins. So you can either use them to send an instruction saying turn on, or you can send an instruction saying turn off. So you can use it to make a flashing light, for instance. Like that. And then we've got some other pins over here. That's what we call these little holes on either side. Can you all see the little holes? Give me a wave if you can see the little holes. Yeah, fantastic. And these we call analog pins. And you can use those to control the different level. Or you can, instead of just saying on or off, you can say it's going to be on a little bit or it's going to be on a lot. Or something. So we have a couple of people who have raised their hands. Do you have some questions? Or was that, yes, you can see the pins. If it is a question, pop it in the chat and we'll get to it as soon as I spot it. Okay, so we've got those two things. And then we've got some power, so we can send out power, a constant amount of power that we can help use to say turn our light on if we wanted to. And we've got this, which is what we call a ground pin. And we'll talk about that a little bit later on when we're talking about circuits and how they work. So that is very quickly what our Arduino is. And you can see just over here, I've actually drawn it so that we can connect an LED, which is what we call a light bulb. This light over here, we're connecting it to a couple of the pins. So if I made this circuit, I could get the LED to turn on. Awesome. All right, so is everyone with me? We're all kind of aware what an Arduino is. Fantastic, brilliant. Now the other thing that we'll be using is called a breadboard. Now I've got to be honest, I've got no idea why it's called a breadboard because it doesn't look like a breadboard at all to me. It's a little white piece of plastic about that big with lots of little holes in it. Can you all find your breadboards in your kits? Fantastic, I can see some, and you can see the little holes in them. Yeah, we call those pins. And what we use, Dane's found his. That's awesome. Although it is again disappearing into his background. So what we use breadboards for is because it makes it really easy for us to make connections between our different electrical components. So between the different lights or the buttons that we can use or whatever. So inside the breadboard, there are some connections. So you can see here on this drawing that I've got, you can see that some of the rows are labeled with letters. And that means that all of these pins along here, they're all connected. Okay, so if I plug something into this pin here, G, it would be connected to another thing that was connected to a pin here called I. So yeah, these breadboards are pretty good. You have to be quite careful that the components are put in firmly so that it's all the way in. But yes, Pauline, we don't normally have problems with the breadboard. But it's a good question. Sometimes they're not very good, but it's definitely much easier than us trying to melt the wires together and tie them up in a knot. So that's how the breadboard works. And at the side, you can see some long lines that are next to a red line and a blue line. Can you all see the red line and the blue line? Give me a wave. Fab. So they are all connected along the line there. So where these green lines are, they're all connected down there. So if I plug something in here, it would also be connected to something that was plugged in here. And breadboards are really super helpful because they just make life a lot easier for us. And I'm all about making life easy for myself. I'm a scientist, and scientists tend to be really lazy and do things the easiest way possible. All right, so carry on. So are you all ready to build a circuit with me? Yeah, give me a wave if you're ready. Fantastic. All right, so the first thing we're going to do is we are going to go to our software that we're going to use, which is called Tinkercad. So Tinkercad is really great because it means that we can build our circuits on the internet, and we can use it to test our circuit before we have to build it. So that means that if there are any issues with connections, we can figure that out quite easily. So if you could all go to your website, go to a browser and go to tinkercad.com, you can see the address just here. All right, and then give me a wave when you're at that web address. While I take a nice sip of water. Fantastic. Got a couple of people ready. It's really good. Oh, awesome. You guys, you're all storming through this. This is brilliant. Fab. All right, I think that's most people that are ready. And now you have your first decision to make. You can either, you can either create your own account, or you can use this class code that I've written here. Now, it's entirely up to you which one you want to do. So if you create an account, then you've got control over it. You can do all of the different things that you want to. If you want to use the class code, that means that I'll be able to see what code you would, we'll be able to see the circuit that you've built and the code that you've done. So it'll help us a little bit to help us if you have any problems. And I can see from the chat, sorry, I've just turned the chat back up, moved the chat back up, you do need a nickname. So if you're joining with the class code, you pop that in and you put in a nickname. Now I've created a whole bunch of nicknames for you. Let me just find out what they are. So I'm going to type them in the chat. So if everybody that wants, so the nicknames, and you can each pick one, is GYO, all small letters, GYO, and then 19986. Try that. It might not let everyone join on the same one. So if it doesn't let everyone join on the same one, I'll tell you the next one. So the next one will be GYO 23001. Fab. And I'll tell you one more, GYO 30971. Oh, I think so. Shrishti has a question, but I'm not sure what the end of it is. It just says, what's the, so I'm not sure what the answer to that is, but we'll get there. So is everybody in? Okay. The class code, so you can see the class code up here. Can you see my cursor? Can you see the mouse? It's up here. I've just highlighted it. There you go. Oh, thank you, Sarah, for popping that in the chat as well. And if the nickname hasn't worked, you can pick the next one on the list. You should be able to see all of the nicknames. Yes. Sarah, can you see the nicknames? Brill. So yeah, if the nickname you tried doesn't work, just try the next one. If you want to use your personal account, that's absolutely fine. Just pop that one in. All right. And while we're waiting for everyone to get all signed in, and we should, once you've signed in, you should see a picture. I'm just going to flip quickly over. It looks a bit like this. So once we're waiting for everybody to get signed in, what I want you to do is to have a think about what kind of patterns and things you could create with different lights. Okay, so start thinking about what different patterns and what different messages you could do to create a beautiful light display. I'm seeing lots of I'm ins in the chat and a few people waving. So do we think we're ready for me to should we do the next bit? Brilliant. Awesome. So if you're joined a bit late or something, if you go to tinkercad.com and then you can pop in, join a class, you can join this class here. This is the code up at the top. And then it will ask you for a nickname and you can pick one of these nicknames to go in. Okay, all right. So I think that lots of people are in now. So let's get started building our circuits. So what we need to do on this, you can see our dashboard. We click on circuits because that's what we're going to make, and then create a new circuit. And that should create, that should leave you with a page a bit like this, which isn't very interesting yet because we haven't built our circuit. But give me a wave if you can see this. Brilliant. All right, so we are going to build our virtual circuit and we're going to get the light turned on. So you can see down here on this side here, all of the different components that you can use. Now, there are lots and lots, but we're just going to use a few this time. So we're going to start with our Arduino, which is just like the real Arduinos you've got. So to use it, you just click on it and drag it over to the main space, so over here. And then you've got your Arduino. So everybody do that, drag an Arduino over and then give me a wave if you've done that bit. Brilliant. Fantastic. And then we want the breadboard, so the other component that we've had a look at, which is just up here. So here's our breadboard. You drag it across, click on it, drag it across, really easy, and just leave it like that. If you want, you can give your breadboard a name, like Bob, or you could name it after Dane if you wanted. I'm sure he'd love that. But I'm just going to call mine name 1. All right, so has everyone got that? Give me a wave if you've got a circuit, a breadboard and an Arduino. Brilliant. Okay, I'm just going to very quickly go back to the, so to get the thing, to get a component, you just click on it in the side and drag it across to the center. Like that. Okay. And now the most important part of our light festival is obviously the light. So we're going to get a light. And that is called an LED. Now that just stands for light emitting diode. It's a thing that creates light. So we're going to bring one of those, click on that and pull it over to our breadboard. And you can see that it's clicking into the different points. So it doesn't matter where you put it. So I'm just going to leave mine here and click it in there. So I've now connected my LED into my breadboard. You can change the color to any color that you want. I think I'm going to make mine blue today because it's a bit cold and I'm feeling, which is the blue color. I always think. So give me a wave if you've got your LED on the thing. I can see some waving, fantastic. And some writing, brill. So we're going to do it online to start with, because then we don't have to worry about connections or about finding all of the different bits. We're going to do it online so that you can see what we're doing. And then sneak preview, you can either create the circuit before the next week, or we will make the circuit next week in real life. Okay, so this is really great. We've got our lovely LED, but we do need to connect it to our Arduino so that we can tell it what to do, right? And we're going to do that with a wire. And wires are really easy. So all you need to do for your wire is click on the place where you want it to start. So you want it to start on the same, the same set of dots, same pins as the bendy leg of your LED. So we click from there. You can see I'm bringing my wire across, and then you pop it into one of the pins that we talked about, the digital pins. So I'm going to put it into number 2, just because that was the one that it went to, but you can pick any of these numbered pins that you want. So once you've done that line, you can give me a wave. If you want, you can change the color of the wire, make the whole thing beautiful, not just the lights. Not just the light. So yeah. Fantastic. We've got some waves going on, which is exactly what we want. Brill. Okay. So the next step is we're going to use something called a resistor. Now, you have to use a resistor because the amount of, what a resistor does is it just reduces the amount of power that gets to the LED, essentially, because we don't want the LED to get too bright and blind us all, or, you know, explode. It won't do that really, especially not in virtually. So we want to get this resistor, click on the resistor and move it over to the other leg of the LED. Okay, so one of the pins of the resistor, one of the legs of the resistor goes on that line, and the other one should go on this line next to the blue line. Okay, now you can give your resistor a name if you like. You don't have to. I'm just going to leave it as resistor number 1, but you can call it anything you like. If you want to delete a wire, it's actually really easy. So I'm just going to draw a random wire here and I'm like, oh no, I don't want that wire. So what you do is you click on it. You can tell you've clicked on it because it gets highlighted. And then up here, you see there's a little rubbish bin. You just click delete and then it disappears. And you can do that with any of the components that you've got. Okay, if you want to undo the last thing that you've done, you can also just click this button here and that will undo it. All right, so give me a wave if you have all of these components there. Oh, fantastic. We've got some great waving going on. Brilliant. Okay, and now the last bit, because this isn't what we call a complete circuit. Now, can anyone tell me what a complete circuit is? You can write it in the chat if you want. Oh, I saw somebody doing hand motions that showed what it was. Brilliant. I've got some great hand motions going on showing what a complete circuit is. And yes, thank you, Claire. Completely linked, and ours electrons can go round in a circle. Yes, so to make a closed path, a closed circuit, fantastic, everybody. So for a circuit to work, you need to be able to go in a whole circle. So at the moment, let's trace the circle together. We started our Arduino here, and then we follow this wire along this wire, and then we can go to the breadboard, which is connected to the LED. It goes through the LED, connects to the resistor, but then it stops. So we need to complete the circuit. We need to do one final wire back to the Arduino. So what we're going to do is we're going to click on one of the pins next to the blue line and draw a wire to the pin on the Arduino that's labeled GND. So that's the ground. That's the negative part of a battery. And that means that we've got a complete circuit. So it goes up here, through the LED, through the resistor, along the breadboard and back to the Arduino. And I'm just going to do one more thing. I'm going to change the color of this wire to orange. And that's because sometimes I find it a bit confusing to figure out where things are going. So I like to say if things are going back to the ground, back to one of these ground pins, back to the Arduino, I always make it orange. And that means that if there's a problem, then I can quickly spot where the different wires are going to go. But you can choose any pictures that you want. All right, so how's it going? Give me a wave. Give me a wave if you've done it. Awesome. Brill. Loads of waves. Fantastic. So now we have a complete circuit. Hurrah, we are nearly there. But it doesn't know what to do with it. So we have to tell it what to do with it. We have to be just like Ada Lovelace and create a set of instructions to control our LED. And we can do that with code. So if you can see up here, this little button that says code, if you press that, then it brings up something that looks like Scratch. So give me a wave if you've used Scratch before, which is a coding language. Oh, lots of you. Fantastic. Yep. So this is just like Scratch. For those of you who haven't, that's absolutely fine. Scratch is a really easy way to give instructions to a computer. So you can see, you'll all see that it's already given you some code. Now these different things are what we call code blocks. They're just instructions to the Arduino. And we don't want these instructions. So all you do to delete it is you click on it and then you move it to the side like that. So you just get rid of it. Okay. And now what we want to do is we want to send an instruction to our light to turn on. Okay, that's the only thing we want to do to start with. But we want to do that forever and ever. So we're going to use something in this. We're going to use a block, one of these code instructions in the set that's called control. So if you click the control button, you'll see all of these. And we're going to use this one here, which is called repeat while. So if you just click on it and then drag it over to your code window, you can see it comes up there, and you can move it around to make it easier to see wherever you want it to be. Now, for those of you who uses Scratch, you can sometimes use forever loops, and that just says to the computer to do it forever. But this doesn't have it. So what we're going to do is we're going to say repeat while, and then we're going to use something from our maths block. So if you click on the green math one up here at the top, all right, and then click on the second one down. This is what we call a condition. It asks a question. It compares two things rather. You click on that one, the pointy one, pop it over there, and it should click in. And if you've got your sound turned up, you might hear a nice pop that's very satisfying. Okay. All right, give me a wave if you've got these bits of code. Brilliant. Okay, I am just going to answer a couple of quick questions before we do the next step. We're using blocks because they're easier and they're quicker, but you can also use different languages to control the Arduino. So if you wanted, you could change to something called text, and then you could type in commands, and we'll talk about that a bit later on in the workshops and the sessions. And for those of you who've done a bit more of Arduinos, it uses the Arduino itself uses a language that we call C or C#. All right. And if you want to change the color of the wire, you just click on it, and then this little thing comes up, this little whatchamacallit comes up, and you can just change the color by clicking on the color. Okay. All right, so we've got repeat while, and at the moment it says repeat while 1 is less than, that's what this little triangle means, 1. But we wanted it to do it forever, so we're going to say repeat while 1 is equal to 1. So you click on the thing in the middle, and then you click on the equal sign. All right, so while 1 equals 1, you do that. Whatever we put in here, it's going to do that as long as 1 equals 1, so forever. And what do we want it to do? We want it to turn our light on. So that's what we call an output. It's something that the Arduino is telling things to happen. So you click on the output one, these blue ones here, and you can see all of these different options, right? And the second one down, is called set pin 0 to high, and that's the one that we want because we want to send an instruction to one of the pins of the Arduino. So one of these digital pins down here. So you just grab on it and you pop it inside the block, just like you would do in Scratch for those of you who've used Scratch. So this is going to say set pin 0 to high. All right, so give me a wave when you've all got that. Fantastic. You're all doing brilliantly. Now, at the moment, if I did this, nothing would happen because if I ran this, if I sent this to my Arduino and I said, okay, Arduino, I want you to turn pin 0 to on. I want it to turn it to high, and the Arduino would go, okay, but then there's nothing connected to this pin 0 here, is there? So nothing would happen. So I need to change the pin to pin number 2, because that's the one that I've connected it to. So if you've got yours connected to pin number 2, then you change that to pin 2, but whichever one of these numbers you've connected it to, you need to change your pin to that number. All right, and then give me a wave when you've done that. Brilliant. Ah, you're all doing amazingly. Okay. All right, and now the moment of truth when we get on. So next week we will make these circuits for real. But what we can do is we can test if our code and if our circuit design is correct by simulating it. And simulating it means just pretending to do it. And computers are really good at simulating it. We run experiments in computers all the time. So if I press this button up here, start simulation, it will run. It will send these instructions to the Arduino, and we will see if I have done it right. Now, I have to admit that at least 3/4 of the time, the first time I write any code, I get it wrong. I've made a mistake. And that's true of all of the people, even the people at my work whose whole time is spent doing this coding. So everybody, if you want to click the start simulation and then see if your little LED turns on. So did you all see that? My LED did turn on. So give me a wave if that's happened. Oh, fantastic. You are amazing, everybody. Oh, brilliant. So if you are having any problems, pop them in the chat and we'll see what we can help. But I am so, so pleased with all of that. Fiat lux, indeed. That means, and there was light. That's amazing. So you can see just by doing these really simple circuits, these really simple code and this really simple idea, we can create a beautiful little light. And that's just one light. We can over the next 6 weeks, we can get the light to flash, we can get it to send messages, and we'll be using things like buttons and light sensors to be able to turn them on and off as well. So over the next week, it would be really great if you could think about how you could use this. So have a play, look around it, think if you want to have lots of lights or only 1 or 2. Think about what kind of message you wanted to do. Okay, and then we will all together next week, we will get started with creating patterns, making rainbows of our circuits. If you do want to build your circuit for real, you can have a look at the recording of this so you can see, you can remember the exact circuit diagram. So you're very welcome to build your circuit for real, but just a few quick things. Little ones, do this with your grown-ups because some of the components are quite small. You don't want to lose them, fall them on the, drop them on the floor or something, because that would be super sad. So do them with your grown-ups so that you can do them together, and you can even teach your grown-ups how you have done these circuits. Okay. All right. Well, thank you so much, everybody. Oh, I've got some more. It worked.
Thank you.
You're very welcome. I'm going to hand over to Dane to say goodbye. If there are any questions I missed, I'm really sorry. You've all been waving and saying thank you and everything so much that I might well have missed some. We'll have a look at the chat and we can email you the answers to any questions that you've sent. Okay, but thank you so much. Dane?
Well, great stuff. I managed to get my little LED to turn on. I hope everyone else or most people did too. I really enjoyed that. Thanks, Sophie. Really clear instructions. I know it was a bit complicated. I struggled a little bit, but found it really easy to follow. But if there is any problem, please bear with it. This is not easy if you've not done coding before. This is all quite new. Browsers and little kind of buttons and flashing numbers and things. It's not straightforward for everybody, so don't feel bad if you haven't got it working. Watch the video, and please come back next week. And why not tell your friends as well? You can get these Arduino kits. The link is on the website, for the festival website. So if you want to kind of pass on the idea and get your friends coding, that would be really great. It's going to start getting dark soon, so I think we need to make some lights in preparation for the Light Festival. But yeah, thanks very much for coming. Thanks, Sophie. Thanks, Sarah, for providing some extra support. And we'll see you all next week. And then we'll get making some really cool lights. Thanks so much, everybody.